I welcome you all for my mathematics session. Today I'll solve a problem in Fourier series. I have already solved problems in Fourier series wherein I have explained what is the meaning of a Fourier series and what are Dirichlet conditions which ought to be satisfied by the function f of x, which got to be expressed as a Fourier series. A Fourier series is nothing but the expressing a given function in terms of as a series in terms of sine and cos in a particular interval. And I have dealt with problems where a function f of x is defined in the interval 0 to 2 pi. I have dealt with problems where the function f of x, which satisfies the Dirichlet conditions and has been defined in the interval 0 to 2 pi. For such a problem, the Fourier series is given by f of x is equal to a0 by 2 plus it is 1 to infinity of an cos nx plus 1 to infinity of bn sin nx, and this a and bn are called the Fourier coefficients and are given by 0 to 2 pi f of x dx, and an is equal to 1 by pi 0 to 2 pi f of x cos nx dx, and your bn is equal to 1 by pi 0 to 2 pi, it is f of x sin nx dx. So these are the Fourier coefficients. You find the Fourier coefficients from this and then substitute here and you will get the answer. Now when it comes to x is equal to minus pi, let us suppose that your values take in the interval minus pi to plus pi, then you see that these Fourier coefficient, this is Fourier series as defined for 0 to 2 pi. Here again it remains the same, but in the Fourier coefficients it is minus pi to plus pi. It is not, for example, this is not like this. It is minus pi to plus pi 1 by pi f of x into dx. So this is my a0 value. This is my, likewise where an value will be minus pi to plus pi and bn value will also be equal to minus pi to plus pi. But the only advantage that you get is if this f of x happens to be an even function, then a0 will be there, an will be there because this is also an even function, a0 and an will be there, whereas the value of bn will be 0. Can you understand? So there is no need to go for finding the value of bn if f of x happens to be a odd function, okay, then, or even function. If it is going to be an even function, no need for you to find the value of this. But if it is going to be an odd function, f of x going to be an odd function, in which case bn will be there and a0 and an will not be there. Okay, because you see that this is an even function, it will be there, but here it is what, even into even will be even, but here even into odd will be odd, therefore this vanishes. But if it is going to be an odd function, this is odd and this is odd, so it is even, whereas these will be odd functions, they will become 0. So you see that when it comes to integration over minus pi to plus pi, you see that the function, that is the integral, will become 0 if f of x given function is an odd function, and if it is even, it is 2 by pi into 0. See, it will be 2 by pi. You can write this as a0 is equal to 2 by pi 0 to pi. I will write it here. When it is even, what is that you will get here? So your a0 will be 2 by pi, it is 0 to pi f of x dx. So for this also it is the same, 0 to pi, 2 by pi, 0 to pi, and you will get. So this is what you get when it is x is equal to minus pi to plus pi. That is, x belongs to, when x belongs to minus pi to plus pi. So this is another type of problem, and here we are going to see something different here. Here, what is it given here? It is not in the interval of the length 2 pi. Here you see that the length is 2 pi. Instead, in this problem, it is given that it is 0 to 2l. It is 0 to a general interval in which length of the interval is what? Length of the interval is equal to 2l. So you see that here the length of the interval is 2l. For such a Fourier series, for such a function f of x, which is defined in the interval 0 to 2l, what is the Fourier series? Now the Fourier series is given by, for such a function f of x which is defined in the interval 0 to 2l, the Fourier series is given by, say I'll write here, the Fourier series is given by n pi x by l plus 1 to infinity of bn sine n pi x by l, and your a naught here, a naught is equal to 1 by l, it is 0 to 2l, and it is f of x dx, and your an is equal to 1 by l, it is 0 to 2l, it is f of x cos n pi x by l into dx, and your bn will be 1 by l, it is 0 to 2l, f of x into sine n pi x by l into dx. So this is the difference that you get. Here you see that your x is replaced by n pi x by l if you go for the values of x taking in a general interval. This is a general interval where it is specific 0 to 2 pi or minus pi to plus pi. Here again you can talk about x belongs to what? Minus l to plus l. You can go for a general interval. Here also the length is what? The length is 2l. Here again the length is 2l. If you go for Fourier, finding the Fourier series of a function x belonging to minus l to plus l also, it will have the same, that is, we have to give the same treatment as I have given for minus pi to plus pi. It will remain the same. Instead of here 0 to 2l, minus l to plus l, minus l to plus l, minus l to plus l, and if f of x is even, these two will not, this bn will become 0. If f of x is odd, bn will not become 0, otherwise these two will become 0. So these are the only differences that we find. So now we will start doing the problem. So here I have explained f of x is given function like this. It is defined in the interval 0 to 2l, and you are supposed to find the Fourier series for this. And I told you that it is as good as your 0 to 2 pi only, but only difference is that because it is a general 2l, we have to, with the f of x is given by a naught by 2 plus an, it is cos n pi x by l, and it is sin n pi x by l. Now we will start finding the value of a naught and an one by one. Now what is your a naught now? A naught is equal to 1 by l, 0 to 2l, it is 2lx minus x squared into dx. So you see that when you find the integration of this, it is nothing but lx squared minus x cubed by 3, and this is 0 to 2l. So this is 2l means 4l cubed minus 8l cubed by 3, that is equal to 4l cubed by 3. So this is your a naught. Now let us find what is our an. An is equal to 1 by l, 0 to 2l, and you have got here what is your this thing, it is 2lx minus x squared into cos n pi x by L into dx. Now you see that here you can straight away go for this, so you can write this as, so let me take this itself as yes. If you want, you can split it into two integrals, or you can do in any way you want. I will go for this 2lx. You can call this as your, see, let me start doing like this. See, you call this as your, so I will write this as, I will write this as 1 by L. It is 0 to 2L. It is 2Lx minus x squared into d of sine n pi x by L divided by n pi by L. Now you see that I write like this. Differential of sine n pi x by L is cos n pi x by L, I get, and multiplied by n pi by L, but you divide by n pi L by L, so you get the same thing. So I write this cos n pi x by L into dx as this. Now call this as your V1 and call this as your U. Now use the Bernoulli's method of doing it. So what is your Bernoulli's method of doing it? It is 2Lx minus x squared into V1. What is that? It is sine n pi x by L into, I take this as L by n pi, and this must be raised to 0 to 2L. Okay, then minus, differentiate this. What is the differentiation of this? 2L minus differentiation of this 2x into, integrate this, you have to integrate this, so it is if you integrate this, it is minus cos n pi x by L. You divide it by n pi by L, so you will get it as L squared by n squared by square. So you raise it to 0 to 2L. Then plus, then you see that you differentiate this with respect to x, 0, minus differentiate with respect to x, 2, into, what is now, minus is there, into, what is the integration of cos n pi x is sine n pi x by L into L cubed divided by n cubed pi cubed 0 to 2n. So this is what you get. Now further differentiation is not possible because this will become constant, will become 0. So this is what you get. Now this is equal to, now you see that this part will become 0, because you see that when I put 0, sine 0 is 0. When you put x is equal to 2L, n will go off, it will give sine 2n pi, but sine 2n pi is equal to 0 for any n. So this will become 0 and this will also become 0, because here again it is sine, so this will also become 0. So what is left with here now? It is minus. So what is that you get here? So it is minus into, see, this is, I will give here 4. See, when you give this, so you are left with what? Minus 2L minus 2x into, take this minus sign also outside. See, minus into minus will make it as plus. Then cos n pi x by L into L squared by n squared pi squared 0 to 2L. So this is all. Now when you put x is equal to 2L, 2L minus 2L is 0. So that is over. Then minus, when you put x is equal to 0, this is 0, so it is 2L into, it is, when you put x is equal to, so when you put okay, when you put x is equal to 2l, x is equal to, sorry, this is when you put x is equal to 2l, when you put x is equal to 2l, it is minus 4l, so this will become minus 4l means minus 2l into, this will become 1, so this is l squared by n squared pi squared minus, when you put 0, this will become 0, it is again minus 2l, cos 0 is 1, so it is l squared by n squared pi squared, so minus 2 will be minus 4 l cubed divided by n squared pi squared. So this is, and here you must know this 1 by l is very much outside, so this, therefore your an is equal to 1 by l, within brackets it is minus 4l squared by pi squared n squared, that is equal to minus 4l divided by minus 4, it is cubed here, it is 4l squared n squared pi squared. So what is that you get here? So your an will be equal to minus 4l squared by n squared pi squared. So this is what you get. So I will explain this once. So you see that what I have not done anything. I have taken this as u and this as v1. I am writing this cos n pi x by l into dx as d of something, so that you get the same thing. Now call this as v1 and apply the Bernoulli's method. U v1 0 to 2l minus u dash, find the derivative of this 2l minus 2x into, integrate this, I have done the integration, plus you differentiate this is 0, differentiate this is minus 2 and take the integration of this, you get this. Now you see that the integration of that is, when you apply whether 0 or 2l, this part will become 0, because sine 0 is 0, sine 2 n pi is also 0, so this will become 0 and this will become 0. Other part I have done here, see, you apply 2l here, you get this result. You apply 0 here, you get this. When you simplify, it is minus 4l cubed by n squared pi squared. Therefore, your an will be equal to 1 by l into this integral. What is the integral value? Minus 4l cubed divided by pi squared n squared. So you get minus 4l squared divided by n squared pi squared. So this is what we get. Now we have to do the bn. What is my bn now? Bn I will write here. What is my Bn? See, Bn is Bn value is, see, you must write it and very patiently do the simplification, otherwise you will not get. See, what is your Bn now? Bn will be equal to, it is 1 by L 0 to 2L, and it is 2Lx minus x squared into sine n pi x by L into dx. Now I will write here, let f of x be equal to, I will write this as 2x into, I will write here 2l minus x into sine n pi x by L. Then f of, here the upper limit is 2, so 2l minus x will be, wherever x comes you put it as 2l minus x, 2l minus x into 2l into 2l minus x into sine of n pi 2l minus x divided by l. So this is equal to 2l minus x. It is 2l minus 2l plus x into sine of, I'll write this as, see when you do this it will be 2n pi, it is 2n pi minus n pi x by l. This is what you will get. Now this is equal to 2l minus x into, these two will go off giving you x, into it is sine of, it is 2n pi minus n pi x by l. Now this is equal to x into 2l minus x. Now sine of 360 minus theta. When you put x is equal to 1, 2, 3, whatever value that you are going to give, it is going to be a 3 times 360 minus theta, 360 minus theta. When you give 2, 1 times n is equal to 1, 2 pi, 360 minus theta. When you give n is equal to 2, it is 4 into that is 720 minus. So like that you see that it will be lying always in the fourth quadrant. It will be lying in the fourth quadrant. So your sine value, see, it is 360 minus theta will always lie in this. So this will lie only in the fourth quadrant. In the fourth quadrant it is all filler teacups. So here cos is only positive. So you see that the sine will remain as sine. Sine will remain as sine, but it will be minus theta. So it will be minus, so this will be into minus sine n pi x by l. So this is equal to minus x 2l minus x into sine n pi x by l. So this can be written as minus x into 2l minus x into sine n pi x by l. But this is nothing but what? Your f of x. So what is that you get? F of minus x. See what is that you get for this? That is, sorry, f of 2l minus x is equal to, what is that? I will call this as, you get this to be f of, this is one, f of minus f of 2l minus x. So you see that f of 2l minus x is equal to minus f of x. See, it is minus f of x. Here you see that what I want to tell you is that if you take this, that is if you that is f of 2l minus x, if it so happens that it is equal to your minus f of x, f of 2l minus x is equal to, what is that you get? Oh, this is equal to what? This is x minus f of x. See, this one x, you just see that this is, what is this now? So x into, I have taken this x into 2l minus x and sine on of this. So you find that if that is f of 2l minus x is equal to minus f of x, that is see, from the properties of definite integrals, from the properties of definite integrals, we know that if 0 to 2a f of x in 0 to 2a f of x dx, f of 2a minus x is equal to minus f of x, then 0 to 2a f of x dx is equal to 0. That means if f of 2a minus x is equal to minus f of x, you will find that the integral value of this particular this thing is equal to 0. So what I want to tell here is that you take this is your f of x, and you change f x to 2l minus, say what is your l here, a here, 2a, it is 2l. So f of 2l minus x, you find that this f of 2l minus x happens to be what? Minus this I have taken to be my x. See here, I have taken this to be my x. Here f of x is this. So this is nothing but I am getting here. So it is minus f of x. So it so happens that f of 2a minus x is equal to minus f of x means the integral will become, that is the definite integral will become 0, taking 0 to 2a of that. So you see that this is the property of a definite integral. So here we find that for this particular integral, this property is satisfied. What is that property? 0 to 2a f of x dx is given. If it so happens that f of 2a minus x is equal to minus f of x, then the integral value of this will be equal to 0. That we can very well prove. It is not a difficult one. So we can prove that. So it is 0. Therefore, that particular condition is satisfied in this particular case. So it is not. So that Bn need not be, you need not take the trouble of finding the value of Bn, because Bn becomes 0. So this property, so I'll write here, so I have given this. Now, so we know that, I will write here, we know that integral of 0 to 2a f of x dx is equal to 0 if integral of, if f of 2a minus x is equal to minus f of x. So this is what we get here. If f of 2a minus x is equal to minus f of x, then the integral value of this is equal to 0. The same thing it happens here. Therefore, the integral value of this is 0. So this, therefore Bn is equal to 0. So we have got this Bn is equal to 0. So now I have got my Bn is equal to 0. An value I have got here. Therefore, what is that you will get here? So what is that you will get? So what is that you will get? Therefore f of x is equal to, it is a naught by 2. A naught by 2 plus sigma 1 to infinity of an cos n pi x by l plus 0, because Bn is 0, that is a naught by 2 is 4l squared by 3 into 2, a naught by 2, then plus, what is your an? It is 1 to infinity of minus 4l squared by n squared pi squared into cos n pi x by l. That is your f of x. So this is equal to, it is 2l squared by 3 minus 4l squared by pi squared into 1 to infinity of cos n pi x by l whole divided by n squared. Now you are given the series like this. So you see that when you give n, you get 1 squared. When you give 2, you get 2 squared. When you give 3, you get 3 squared. So you see that this series can be got, so this series can be got by just inspection. You can say that here only when you take x is equal to, because we know that cos n pi is equal to minus 1 to the power of n. When you give n is equal to 1, it is cos n pi, I'll write here. Cos n pi is equal to minus 1 to the power of n. When n is equal to 1, it is minus 1. When n is equal to 2, it is minus plus 2. When plus 1. When n is equal to 3, it is minus 1. When n is equal to 4, it is plus 1. So you see that for even values, it is plus. For odd values it is minus. So this we know. So here you see that plus minus plus minus plus minus. So this can happen only when what? It is cos n pi. So this series can come. So one can come, I'll write here. The series can come only when x is equal to n. Only when the series, I will write here, the given series can be got only when x is equal to n. Therefore, I'll call this as your 2. 2 becomes f of L. Put x is equal to L. It is 2L squared by 3 minus 4L squared by pi squared. It is 1 to infinity of cos. See, you put L. So this is equal to 2L squared by 3 minus 4L squared by pi squared. It is cos n pi by n squared. So what is it equal to now? So you have got this cos n pi. Cos n pi value is minus 1 to the power of n. So what is that you will get here now? So 2L squared by 3 minus 4L squared by pi squared, A2 within brackets. So when you give n is equal to 1, so it is minus 1 by 1 squared. N is equal to 2, 1 by 2 squared. N is equal to 3, so it will be minus 1 by 3 squared. N is equal to 4, 1 by 4 squared dot dot dot. That is, so what is that you get now? F of L is equal to f of L is equal to 2L squared by 3 minus 4. Now take this minus sign inside, so what is that you will get here? Plus 4L squared by pi squared within brackets 1 by 1 squared minus 1 by 2 squared plus 1 by 3 squared minus 1 by 4 squared. So this series I have got here. See, I have got here. Now you just find the value of this. Now f of L, what is our f of L? F of x is equal to so much, because it is continuous in this function 0 to 2L. So f of x is equal to 2Lx minus x squared. F of L is equal to 2L squared minus L squared, that is equal to S squared. Therefore, L squared is equal to 2L squared by 3 plus 4L squared by pi squared into 1 by 1 squared minus 1 by 2 squared plus 1 by 3 squared. This is what you get. Take everything to the left hand side. So what is that you will get here? So you will get this to be, this pi squared you can cancel throughout, L squared. So you will get it to be what? 1 by 1 squared minus 1 by 2 squared plus 1 by 3 squared dot dot dot, and this is 4 by pi squared is equal to 1 minus 3 by 2 by 3 that is equal to 1 by 3. So this implies your 1 by 1 squared minus 1 by 2 squared plus 1 by 3 squared minus 1 by 4 squared plus dot 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 is equal to 1 by 3 divided by 4 by pi squared, that is equal to pi squared by 12. Therefore, what is that you get? Therefore, so this is all about this. So we have got the answer, and this is the answer for this. And understand that this is a different problem that I have done today. And as I told you, this may be another way. Here I have written, here it is not required. So you see that there can be problems instead of 0 to 2l, we have got 0 to 2l or x belonging to minus L to here. It is like this. Minus L to plus L. If in this case, then you have to find out whether that function f of x is odd or even. Accordingly, you can get rid of some of the functions. So it will lessen your labor of finding the Fourier coefficients. So in this way we can do. I'll do more problems in the coming days. Thank you.